Let's continue on in our Chapter 1 notes with Section 1.8. So we're going to look at some commonly used links and joints. So the first one we're going to look at is the eccentric crank. So in many scenarios, it's just unfeasible to fit an actual link in between 2 points about which, you need something to rotate. Just, due to bearing size and size constraints and whatnot. So a common solution is to design the link as an eccentric crankshaft. So we can see down in our image 1.23. So we can see two representations of an eccentric crankshaft, and we can see C, the model. We can see how that would look when we drew it in a kinematic diagram. And this model is something we've seen before. We just have to know that if we're looking at something like this or like this, then we need to draw it like that. And then its motion will look something like that. Next, we'll look at pin in a slot joint. So this is a higher order joint because it allows rotation as well as slide. So, and to simplify the kinematic analysis, two primary joints will be used to model this. We can see that in our figure in B. We can see that we have the pin along with the slide. So we take our higher order joint and just break it down into two primary joints to make it easier for us to model. Screw joints. So screw joints permit two relative but dependent motions between the links being joined. And for our purposes, we'll just model this as a slider because what we really care about is not so much the rotation, but the movement in the lateral direction. So below we have a little kinematic diagram that's showing our screw. And we see that we just have it modeled as a slide right here. We can also see up here, we have that pin in a slide that is in turn modeled as a slide with a pin in it. Section 1.10, the 4-bar mechanism. So in this class, we are going to take a good lengthy look at 4-bar mechanisms, and it's going to be something that when you get a problem, you'll probably look to break it down into a 4-bar mechanism or a 6-bar mechanism right from the jump, just to simplify things, to wrap your mind around it. So we will be diving much deeper into the 4-bar mechanism. So it's the simplest and most common of linkages. It's a combination of 4 links, one being designated as the frame, connected by 4 pin joints. So because the 4-bar mechanism has 1 degree of freedom, it's constrained or fully operated with 1 driver. So typically the pivoted link is connected to the driver or power source, and it's called the input. And the other pivoted link is attached to the frame and is designated as the output link or follower. So we're going to be defining different types of 4-bar mechanisms. So some of the parameters we'll look at to help us define this is the length of the shortest link, length of the longest link, length of one of the intermediate length links, and length of the other intermediate length links. And Grashoff's theorem states that a 4-bar mechanism has at least one revolving link if S plus L is less than or equal to P plus Q. And likewise, the 3 non-fixed links will merely rock if S plus L is greater than P plus Q. So let's take a look at some categories of 4-bar mechanisms. So the first one we'll look at is a double crank, and we can see in our table 1.2, that we have a definition for it, S plus L being less than P plus Q, and the shortest link being the frame. So the shortest link being the frame, you might think that's a little weird because some of the things we've looked at before, the frame gets kind of wonky, but the frame being defined as this length between these 2 points. And we can see double crank, it's fairly intuitive. Both of these points out here make a complete circle. We look at the crank rocker, right? We have this point over here making a complete circle, while this point will only rock as this point makes its complete circle. Double rocker, same kind of ordeal. Both points will simply rock back and forth in conjunction with one another. Change point. A change point is just defined as when this point travels down, this point also travels down, and they create a straight line. And the triple rocker is the same thing as double rocker, we just have 3 now. Section 1.11, slider crank mechanism. So this is a very commonly used mechanism that we're gonna take a look at a lot. And this mechanism also consists of 4 links, with one being designated as the frame. But this one is just slightly different in that we have 3 pin joints and 1 slide joint. We see that modeled up here with this pump mechanism.